Hello. So today we're looking at derivative notation. So let's see what's going on here. So using the definition of a derivative, find f prime at x equals 3, where f at x equals 3 over x minus 4. And then in part B, we're asked to find dy dx, where y equals x squared minus 2. So there are different ways, as we can see, to denote the derivative of a function. So why don't we go back up here and have a look at the different ways to denote the derivative. So if we're given a function f at x, we can denote the derivative as d prime x or dy dx. There's also, sometimes you may see this, big D, little f, and an x. Most of the ways that you probably see are the first two. Okay, so now let's go back to our first question. So using the definition of a derivative, we're looking for f prime at x equals 3, where our f at x, our function, is given by 3 over x minus 4. Okay, so f prime at x, we're going to use the definition. So let's change this to 3. Limit as x approaches 3 of f at x minus f at 3 over x minus 3. All right, so now let's start plugging things in. Limit as x approaches 3. So f at x is this 3 over x minus 4 minus, and then we have 3 over 3 minus 4 over x minus 3. Okay, so let's start simplifying. All right, need a bit more space. Let's make it a bit smaller so we can fit everything in. Okay, so equals limit as x approaches 3 of, okay, let's have a look. What's going on here? We have 3 over x minus 4 minus 3 over negative 1 brackets times 1 over x minus 3. Okay. All right, so what we're going to do is try and do this subtraction, but we need to put everything over a common denominator. So we have 3 times the negative 1 minus 3 times x minus 4 over x minus 4 times negative 1 all over 1 over x minus 3. Okay. Okay, so now let's see what we can do to try and simplify all this. What can we do? So the goal is to try and factor this x minus 3 out. So we need to find a common factor of x minus 3 in the numerator. So let's pull out the 3, and we're left with, actually let's pull out the negative 3, and we're left with 1 plus x minus 4. Let's see if that helps us. In the denominator, we have negative x minus 4 times x minus 3. Okay, let's scroll up a little bit. Oh, of course, we're running out of space. I write too big, I think. What do you think? Okay, so in the numerator, we have negative 3 times x minus 3. It's perfect. 1 plus negative 4 is negative 3. And negative x minus 4 times x minus 3. So we can cancel out the x minus 3, so that works out well. And we're left with the limit as x approaches 3 of negative 3 over negative x minus 4. Okay, let's scroll over to the right and do the final substitution. This equals, let's cancel out these negatives. We have positives 3 over 3 minus 4, which equals negative 3. So that's the derivative of our function at the point 3. Good. All right, so now part B, we're asked to find dy dx, where y equals x squared minus 2. And we want to do this using the derivative. Okay, so dy dx equals, this is interesting. Okay, so let's rewrite this. I think it's going to be easier if we rewrite this as in function notation. I'm just trying to think. Oops. Limit as h, my mistake. H approaches 0 of f at x plus. Okay, let's be a bit more precise. So now we have f prime at x equals the limit as h approaches 0 of f at x plus h minus f at x over h. Okay, let's start plugging things in and see what happens. So f at x plus h is x plus h squared minus 2 minus x squared minus 2 all over h. Okay, limit as h approaches 0 of, okay, let's try and expand this there. So x squared plus 2xh minus h plus h squared minus 2 minus x squared plus 2 all over h. And what do we get? Well, we can cancel out the 2's, we can cancel out the x squareds, and we're left with limit h approaches 0 of, well, we have a common factor of h. Let's factor it out. H times 2x plus h over h. We can cancel out h in the numerator and the denominator. And we're left with the limit as h approaches 0 of 2x plus h, and this equals 2 times x. Good. Okay, so that brings us to the end of our session. Strange. So tough getting used to a new whiteboard, but it's quite nice. Miro is quite nice. It's got some nice features. So if you have any questions, give us a shout at info@raisemymarks.com or give us a call day or evening, and we'll be happy to help you. Thank you for watching.